a lot of the times the parents I'm working with want to support their kids in using technology in a creative way, in a productive way, but they don't know where to start because they don't know how to program neither. Bună ziua, eu sunt Stefania, vă mulțumesc mult de invitație și vreau să vă doresc la mulți ani pentru aniversare. Știu că sunt între pauza de masă și după multe prezentări de dimineață, așa că și o să prezint în engleză, pentru că cercetarea mea și majoritatea proiectelor sunt în engleză și mi-e mai ușor. Dar întrebări îmi puteți pune și în română și în engleză, mă întrerupeți când vreți. Dar până să încep, aș vrea să facem așa un joc. Eu lucrez foarte mult cu copiii de mulți ani și știu că atenția, dacă stăm și ascultăm pe cineva vorbind, după 20 de minute nu mai funcționează. Plus că dacă a stat toată ziua jos, am ascultat și de la Ane despre neuroștiință, creierul. Deci, ca să activăm așa un pic mai multe circuite, v-aș ruga mult să vă ridicați și o să ne jucăm rock, paper, scissors. Știți jocul? Vă rog să vă opresc. Dacă data viitoare avem mai mult timp, o să ne jucăm toată sala și cine câștigă se joacă cu persoana următoare și până la sfârșit, da, trebuie să facem un algoritm. Okay, so I'm going to switch to English. What I'm going to talk about today is about what do people think about machines that think. How many of you have heard about artificial intelligence or machine learning? Can I see a show of hands? Okay, great. So I don't have to explain what it is. Before I joined MIT Media Lab, where, like Ciprian was saying, where I'm doing research, I've done a couple of things, very, very curious, just like the kids that I'm working with. I started an organization called Hackidemia, coming from hacking with kids and trying to hack the way kids learn. Not in the sense of breaking into bank accounts, but in the sense of reverse engineering. And then we did also a couple of camps, like MakerCamps, trying to create makerspaces in shipping containers in Berlin and China. A project all over Africa called Afrimakers, connecting like young engineers like yourself or students with kids and use digital fabrication and coding to solve problems in local communities. So this is kind of like my background and where I'm coming from. And I always struggle when people ask me, what are you, Stefania? What's your background? Because I've studied a couple of things like education science with new technologies and communications, but I'm also a hardware engineer, software engineer, researcher, but I like to define myself just as a curious person because I think when you're really interested in something, you're going to learn all the skills you need to solve a problem or build something. So this is where I am now after doing what I showed you before. I am part of this group at MIT Media Lab. This is Media Lab. It's kind of a unique part of MIT in the sense that it functions in a very different way. It just celebrated 30 years when I started. We had the same birthday. And it has, let's see if this is working. I'm going to do this. It has 26 research groups, and it prides itself with being anti-disciplinary. So a lot of the groups are doing research at the intersection of different fields. Personal Robots is doing research at the intersection of robotics and AI, and also like learning, education science. We also have biomechatronics, where they're building like exoskeletons and prosthetics. We have Living Mobile, where we have like people doing games for future planning of cities, and so on and so on. I could go on just talking about Media Lab for an hour, but I'm not going to do that. Some of the things that came out of Media Lab that people know around the world are things like the e-ink that we use in the display of Kindle, Mindstorms, Lego Mindstorm, that was actually started there. Seymour Papert, actually, who inspired the whole philosophy of learning that we have at Media Lab, had a book called Mindstorms, which I highly recommend you guys check out. Yeah, Guitar Hero also came from there. Glass printing technique, this is very new. Different formats for files like MPG4 and Scratch. So the first group that I joined last year was called Lifelong Kindergarten. That's actually a name of a research group. And one of the main projects in this group is this platform called Scratch. How many of you heard of Scratch? Okay, great. I'm glad I'm going to tell you a bit more. So let me show you a video to explain how Scratch works.
I was searching for interactive programming language on the internet, and I came across Scratch. As soon as I shared my first project, I got instant feedback, and I was like, okay, I want to continue with this.
I remember my first project was a super simple animation. I'm still actually really proud of my first project. It opened my eyes to the different possibilities that coding can present.
So I've been drawing basically since preschool when I learned how to hold a crayon. I think making art with Scratch is different because I can collaborate with other people and make something interactive that other people can use.
There was a song that said, "Happy, happy birthday." I put Scratch in there. It just became an instant hit on the site and inspired so many people to make their own songs and remixes.
Anyone can do anything with my project, and sometimes it's really funny how they change things at the end. It just goes to show like how much you can actually do with all the things you have in Scratch.
When you're looking at other people's projects, you're engaging on such a different level, which really encourages this kind of mindset of seeing yourself and each other as makers of things and not just consumers.
I never thought that I could do like the coding part. Like I thought like I have to wait till I'm a grown up and like hire someone to code it for me, but then I was like, hey, I can actually do this myself.
It gets more complex, but once you know the basics, you can add on to your knowledge and move at your own pace.
If you like solving problems, if you like drawing, if you like making music, if you're into anything, Scratch is for you.
Right, so Scratch.mit.edu has been around for 10 years. It is the largest community of kids online learning how to program. And it actually exists in Romanian. It's translated in Romanian as well, and it's available for free. So if you have kids or no teachers, tell them about it. It's pretty cool to get people started to code. And what I really like about this approach, like you saw in the video, is that it's not from a typical pedagogical or academic way, like you need to learn variables and functions. It starts with people's motivations and what they love to build. Like if you like to do an animation, yes, you're going to learn how to use conditionals and loops, but that's not the point. Coding is just a tool, right? It's a cool, and in this case, it can be a tool of creating things, expressing yourself, building your identity. Most of the kids, actually, this is quite fascinating, have like 2 or 3 different profiles on Scratch, and they use like different profiles to build different types of projects. So yeah, what kids learn with Scratch, they learn how to think creatively, how to reason systematically, and how to work together. I think the thing that made Scratch huge is the fact that you can share your projects and other people can remix what you've done, just like open source in coding, right? So what I'm interested in is how do we connect this to the physical world? I really like when I can touch things, when I can build things with my hands, when I can think with materials. So one of the many things that I've done in LLK, in Lifelong Kindergarten, was to create a series of what I call Scratch extensions to allow kids not only to program things in this machine, because this becomes kind of like your window towards the world, but actually get out and program things with all the objects and all the other things in their home around them. We use an Arduino board that has multiple sensors and connected it to Scratch so kids can program it easily, but then connected that to the Spotify extension. So imagine if you could connect anything on the web with anything physical. Like if you had your plant lighting up when the space station is right above you, how cool would that be? And that's actually already possible. So if you look at scratchx.org, there's a ton of things that you could plug in and connect and enable kids to program. So after that, one of the things that really caught my attention was the rise of these kind of devices. So here we see this doll, which is seemingly not threatening at all, right? It's just a simple doll. But it turns out that this is actually a very creepy doll. Her name is Kayla, my friend Kayla, and it has a Bluetooth connection, and it's supposed to be part of this new generation of smart toys for kids. It's very cheap. In the US, you can get it on Amazon for $29. In Germany, it got hacked 2 days after it was released, so people could listen in on what your kids are saying at all times. So it got banned. You can't buy it in Europe, right? Because here we have better policies and better regulation. But in the US, you can still buy it for $29 on Amazon. This is Aristotle, which was supposed to be the first Alexa for kids. How many of you know Alexa? Okay, great. So this was done by Mattel. Mattel is the largest toy manufacturing is a huge business, huge, right? And we can talk about gender separation and a lot of other things. This was Mattel's attempt to bring smart personal assistants into kids' room, into the nursery. Now, the thing with this device is that it also had a camera, so not only it would track everything your kid is saying, but it would also film and record what your child is doing. And the big question that comes with that is what happens with that data, and also what happens in terms of advertising. Like never before, companies were able to track us from like 5-year-old, 4-year-old until we are adults and profile us, right? So this was like a big concern for the parents of the children, and they signed a petition. There was like more than 15,000 parents. So this company, Mattel, after investing a lot of resources to create this product, they were planning to launch it for Christmas, they had to pull it out. Why am I showing you this? I don't think necessarily that AI for kids is bad at all. I actually think it's a huge opportunity and we can learn a lot of things. What I'm trying to show here is how senseless and naive are our approaches to bring products to consumers, bring products to kids, without actually understanding what are the implications, what is the effect that these technologies can have on their development, and how do we involve families, kids, policymakers, educators into the conversation. So when I saw this and I realized how ubiquitous these devices are becoming, there are more than 10 million homes in the US that have an Alexa, I decided to look up and see if there are any studies that are looking at how these devices are affecting the kids. And what I found was only 2 papers. This was the first one, and notice the dates, they're all very recent. This one shows actually how much children copy parents in the way they talk to Siri on their phone. Like if the parents are rude to Siri, the kids are going to be rude to Siri. If the parents are polite to Siri, kids are going to be polite to Siri. So they are really like, even if these devices were not made for kids, kids use them, right? So that's important. The other study is this one, which was actually last year. It was a study on this generation of smart toys, showing how little actually kids and parents knew about the data that is being collected, and how poorly this information was communicated to them when they were like activating these devices. However, in these 2 studies, I still didn't find the answer to my question, like, what are kids learning with these devices? How are kids using these devices? So we decided to do a study at Media Lab, where, and this was the first pilot study of its kind, where we had children interacting with 6 different smart devices, everything from the Alexa to Google Home, but also toys like Kayla and Cosmo and chatbots. We took the chatbots that are most popular among kids. And I'm going to show you actually a quick video so you can see for yourself how the kids interacted with the toys. Let's see.
Today's children are growing up with social, intelligent, and relational devices found in their homes, in their schools, and in the toys that they play with. What do children think about machines that think? To engage this question, we ran a study where 27 children between the ages of 3 and 10 interacted with different devices. They played games. They asked questions.
Alexa, what does dinosaurs eat?
Dinosaurs are diverse.
Then we asked, is it smarter than you?
I think she's not. Well, I think she's
Excellent.
smart.
That's
but
smart.
I'm
So
in
Finn
the
said
middle.
that she's not as smart.
Is it like a friend?
Well, he know my name, so he.
Does it have feelings?
He actually asked Google, and she said, yes, I have feelings.
We saw that children anthropomorphized AI in playful ways.
I don't have a boyfriend.
The voice and language determined how intelligent and playful the AI seemed.
Google Home was like, I know everything. You can ask me anything. But Julie was like a normal person. She sounded like a normal person. And it felt like she actually understood what I was saying to her.
We both believe that researchers and device makers should pay more attention to how kids interact with intelligent toys. As we look into the future, adults are thinking about self-driving cars, personal assistants, while children are more open to imagine new possibilities of interacting with intelligent devices. In the findings of our study, we noticed that children perceived agents as friendly and truthful. Our results showed that most of the older children thought the agents were more intelligent than they were, while the younger children weren't so sure if the agents are smarter than they are. Exploring this agent's nature could also make us think about our own nature.
Hey Google, who's your best friend?
It's hard to pick, but if I had to, I'd pick you.
Yeah, that's endearing and scary at the same time. So what was interesting, like I mentioned in the video, is that the older children from 6 to 10, even if they would ask questions that Alexa or Google Home couldn't answer, they still thought it's more intelligent than they are. Why is that? I mean, I think there are multiple reasons. One is because when you start going to school, you associate intelligence with access to information, declarative knowledge, not conceptual understanding, right? So the fact that this machine is basically like a speaking Google search engine, for them meant it is very intelligent. So why is that important? It is important because we did this to show that kids believe what these devices are saying, believe these devices have feelings, trust the information that is being given to them. And we think it's very important to actually foster an environment of criticality. Teach the kids how to be critical towards the answers they're getting from these devices. Teach the kids more about how these devices are working and how they can customize them and teach them things. If he doesn't know the answer to a question, it's your opportunity to teach, and by teaching, you learn. So one of the things I built was a Scratch extension to start teaching kids notions of how you would train a smart robot, a toy, and how you would train it to play rock, paper, scissors with you. So let me show you how it looks like. This is an open source robot. And you can show it how to draw something. And sometimes it makes mistakes, and it's so cute. But that's okay, because then you learn how to teach it to do it properly. This is how the code looks like. For younger kids, they can also just program it by showing it different images with QR codes. So they can make it act happy, or make it behave like a dog. This is the dog. Or play games with it. Teach it how to play rock, paper, scissors with them. I'm using two extensions here, the leap motion and the robot extension. Or make it collaborate with other robots. This was their favorite thing. Make it do music, and so on. So this was one way to kind of give them some insight into how you would train a robot, how you would program a robot, how does it work. But then going back to the study that I just shared with you, we realized that we didn't ask a deeper question. When we asked children, is the Alexa smarter than you or not, we didn't ask actually, how are machines intelligent in a different way than humans are intelligent? When they say smart about the machine, is it the same type of smart that you would say about your friend, right? So in order to answer this question, we did another study where we had actually 60 participants, 30 families, parents and children. And the goal for this study was to actually compare different agents. Compare a robot solving a maze, compare a mouse solving a maze, and then have the participants solve the maze themselves. And then say which one was most intelligent, and in which way, describe the way in which they were solving the maze. We choose solving a maze because when you have like a goal-driven activity, it's easier to determine success and know if you did the right thing or not. So I think there's a video about this. What was very interesting is that initially I didn't want to have the parents participate in the study. But I discovered, like, initially we asked the parents to do the study as well to keep them busy. And I realized that the way the parents were explaining, the way the robot solves the maze, the way the mouse solves the maze, was very similar to the way the children were explaining it, even if they were in different rooms and didn't hear each other. So they were really like mirroring not only their choice of the robot is smarter or the mouse is smarter, but they were actually mirroring their explanation. If they would say, well, the mouse knew how to solve the maze because it smelled the cheese, so referencing the sensory capabilities, right? Or the robot knew how to solve the maze because it has an AI and it has sensors. And what was very interesting is that actually their choices, here you can see the parents doing the study and the kids doing the study. They were babies as well. It's interesting because most of the parents have multiple kids, so you can also compare with brothers and sisters. But what was interesting is that they would mirror each other like say the same thing in both directions. So we would have like pairs of parents and children saying, well, the robot is stupid because it's programmed. And the mouse can learn over time, so it's intelligent, and I'm intelligent because I can learn over time. Or you would have pairs of parents and children saying, well, the robot is super smart because it was programmed, so it can remember, and the mouse will stay the same. So you can see actually that it's very hard for us to make up our mind. What does it mean to be programmed? And even understand at which point do you get emergent intelligence? At which point the fact that your robot can sense light or an obstacle becomes intelligent, right? This idea of emergent schema is very hard for people to understand. So one way to do that is by poking at the nature of the device, by trying different things and seeing what happens. And I think what really helped in this study is the fact that when the kids and the parents were solving the maze, they were teleoperating the robot. So they could actually see what the robot was seeing and understand how the machine was making decisions from the perspective of the machine, right? So that's what motivated me to actually pick for my research project. This study around like families. So what does it mean to grow up with AI for families? And how can we make children and parents learn together and collaborate? So one of the things that also motivated me is the fact that if you look at families today in airplanes at home, when they want their child to be quiet or be, okay, they will give them a tablet. Or if they see their child on the computer, it's doing technology, so it's okay, and they're fine with it. So I think like the learning culture of the family is so important, and we really need to change this. So how do we go from this to a meaningful life where we use devices for what they are, tools, to actually improve better learning and communication with other people and with people in our family? So I created this platform called Cognimates because it's like a playmate, but you're learning with it. And it's meant to improve collaborative learning for families with intelligent agents. This is how the system looks like. I'm using a robot called Jibo, which is a social robot. It's an intelligent robot for the home. And I built a visual programming language very similar to Scratch for Jibo. But what's interesting is that you can pair program. You all know, I'm sure, how important pair programming is. And in general, like collaboration. So here, multiple children can program one robot at the same time, or children and parents can program the robot at the same time. And the logic behind it is to use what is a student modeling, which is called Bayesian knowledge tracing, which is basically doing this. Imagine the robot will give you a task. Can you make me spin 5 times? And then the parent would make a program, the child would make a program, and then the robot can see who got it right. And then it can tell either the parent or the child, can you explain, mommy, or can you explain, daddy, how you did it, right? And if we want to go a bit more in depth, it's basically asking similar questions multiple times to actually see if you get a concept, and then making predictions about how much you're going to get, how much you're likely to get the next concept. And doing this kind of collaboration, this mediating the conversation between kids and parents. This is how the platform looks like, the visual programming platform, and examples of different learning activities that kids and parents and grandparents can do with the robot. They can play games, they can teach it how to recognize faces, how to tell stories. And I have a quick demo, because the best part of this is not only that the robot can talk to you and see what you're programming and tell you if you got the concept right or not, but it can actually guide you how to learn. Right? So, and talk to you and actually challenge what you're doing. Never before we had this opportunity to have a reflective conversation with the thing we're building. Imagine you would, I don't know, what's a funny example in Romania? Imagine you would go in your garden, right, and use like something to pick an apple, and the tool you're using would tell you, I don't want to pick this apple, right? But it's this kind of conversation with the materials are using is very interesting, and this is a demo of the platform.
I would like to know your name, so let's do a program that allow me to learn it. Let's start with the green flag block. There you go. You did it. No, I need you to help me ask a question. For that we'll need the ask block. See if you can find it. Awesome. Now you need to find the say block. You can make me say anything, try it. Hi. Cool. Hey, Stefania, would you like to
and
learn
so on.
something
It
new?
works on different platforms, not only the programming platform. Now, why do I think that's important? A lot of the times, the parents I'm working with want to support their kids in using technology in a creative way, in a productive way, but they don't know where to start because they don't know how to program neither. Now, having an agent that can scaffold that learning and get them started is super important. Same goes for schools. My mom is a teacher in Romania, and I showed her Scratch in Romania, and I was like, okay, you should use it with your students. And she was like, oh, first I need to learn it very well, and then I'm going to go and explain. And then I was telling her, you will never learn as fast as they do or know as much as they do. But your role will have to shift. You will be a facilitator. You would ask the hard questions. And this is what the current platform is helping. It's not making people obsolete. It's not making parents obsolete or teachers obsolete. It just helps us to do what we do best, like have critical conversations, learn together, and learn at the same time. So I wanted to show an example of the most fun and simple program that a girl that never programmed before did with this platform. So she saw Jibo and she was trying to make him talk and move and dance. It can do a lot of things. It's a fun robot. And then she wanted to play a game with Jibo. So she made this program that would allow her to play hide and seek with Jibo. So basically the way it works is that the green flag allows you to start the game, and then turning attention on block means that the robot would constantly look around and see if there's a changing sound or a changing person coming into the frame. So it's constantly paying attention. Then she's using a conditional to see if the number of people that the robot can detect is greater than 0. That means if the robot can see a person. And if the robot can see a person, it will say, I see you. And she used this, like, this is what? How many lines of code? How many blocks? We have 6 blocks, right? With 6 blocks, she played half an hour hide and seek in the room with the robot, right? And then the conversation moved where she wasn't only in front of the screen, she was actually playing in the space and understanding when does the robot seeing her or not? How can she change it? How can she play with multiple people, right? So also I love to show this image because even on Scratch, like, the collaboration is online, but not in person. And I love when people decide to program with 4, 5, 6 hands, the same robot, and collaborate and change ideas and negotiate ideas. And for the parents, it was a bit hard to get them involved in the beginning, but then I would just give them the tablet, and I'm like, you don't need to program, just try things out. And then after a while, they were like getting more and more curious. And actually, right when I'm going back to Boston, I'm going to do a workshop with 20 families, and I decided to also have a workshop for parents first, so they get comfortable, and pairing parents with each other before they pair with kids. Okay, so what am I trying to achieve with this? It's not only about how can we use AI and robots and these technologies in a useful way for learning, but I also think that the relationship between kids and parents needs to evolve, right? So I really think that the growth mindset will be inspired to kids, just like you saw in the maze study, if the parents have the growth mindsets, because kids really copy what their parents say and do and the way they think. It's very intuitive, and you're going to say, yeah, you're telling us this. But it actually matters much more than their technology trainings or if they learn how to code. It really matters that they see someone in the family that is like fostering their curiosity, trying to learn, not giving up, trying to change their ideas. So I'm trying to use this agent, which can be a robot or an Alexa or a thing on a computer, it doesn't matter, it's just a tool, to actually reach a balanced partnership between children and parents, right? Where parents are also learning from their kids, where parents respect and accept the ideas that their kids have, where they reflect together, they ask questions together, and they develop a more healthy family learning culture. So you're going to ask me what's next. I know I'm giving you a lot of information. Next is to try actually this platform in many different countries. This is a workshop I've done in school in Saudi Arabia recently. These are workshops, and we've done it in Colombia. I'm going to do one with refugee kids in Berlin at the end of March. I really want to do some of these workshops in Romania as well. Maybe you can help with it. And also involve grandparents, because many times parents are busy, they go to work, they don't have as much time. I think it's really a shame that we use our betters so little, right? Like these people that have so much experience and have lived through so much that are left alone in a senior home or, so these are a series of workshops I've done over the summer in senior homes in Boston, where actually elders program robots. Yes, seniors can code also. Their fingers don't always work on tablets because they're too dry, and we should talk about that, like how can we design technologies that are more inclusive. And besides the Jibo platform that I showed you, I developed many other extensions, like the Alexa extension. So my dream is, I was actually telling Christian yesterday this, those 10 million homes that have Alexas, I'm imagining what would happen if kids would start to hack them overnight. So I made a Scratch extension for Alexa where you can teach it new things, what your favorite band and your favorite movie. You can leave messages for other members of your family. You can make Alexa execute code on your computer via voice. So let me show you a quick video how it works. So first you add it to Scratch, and then you create a user account. Alexa, ask personal chatbot to connect to 96644. It's very raw. This was finished 2 days ago, so.
You are connected to 96,644. Ask me anything.
What is my favorite color?
It is red. Ask me anything.
Do I have any messages?
There is a message for you. It says, it's very chilly out today. Ask me anything.
Run block set 1.
Alexa, how are you?
To be honest, it's been kind of a rough day. Just kidding. I'm great.
So that's going back to what I was describing in the beginning. Imagine if kids could program anything in your home, right? So yeah, I would have loved for us to do a workshop instead of me sitting in front and talking to you. So because we couldn't do that this time around, I wanted to give you a couple of resources so you as well can play at home if you want to learn more about machine learning or use it in a creative way. There are 2 resources. One is this website that I love. I'm going to send the slides as well, so don't worry. But if you want to take pictures, go ahead. This website is called Teachable Machine. And basically what it does, let me see if I can show it in real time very quickly. It's using your webcam, and then you can train, it's using actually neural networks in, neural nets in the browser with DeepLearn.js, which is crazy. So I can train it to recognize my head in this position, and then recognize my head in this position. And then it's going to be very interesting because the lighting is not so great. But now you can see it's kind of seeing that I'm changing the direction of my head. And you can map that to different outputs. But you can imagine how fun this would be if you do it like with different people. So it's like the child and the parent, and then it says your name when the different face comes in front. And you can add many different nodes, right? And then you can also talk about edge cases. What happens if I try to make it recognize my right hand against my left hand? How many examples does it need? When does it work? When does it not work? How can I add new outputs? How can I add more inputs? What happens if I actually connect this to the camera of my robot that walks around and starts recognizing objects as it does that, and so on. And the other website was this Machine Learning for Kids UK, where they actually use Scratch, but you can train programs in Scratch. And they have a lot of activity sheets, and it's a lot of fun. Taking a step back, I didn't do this presentation in the right order, but it's okay because I know you can follow. What's the big picture here, right? I talked a lot about smart toys, AI for kids, and I'm sure you heard all the talks about AI is the new electricity and self-driving cars, and it's going to take our jobs, and so on and so on. From a scientific point of view, I think it's really like a new paradigm. Like, we went from empirical research, where we really observe the nature around us and try to make, logic deduction from that, to theories where we try to explain, make a theory that explains every phenomena, to computation, where we thought even the way we explain our brain and even the way we reference to the way we learn or communicate with each other is very much based on this paradigm that come from computation. But the next step is going to be data exploration. And this is very critical because only a handful of companies have ownership over the largest pool of data about us, right? And that's why it's important from the youngest generations to the oldest generation to start to learn more about how these things are working and what kind of data is being collected, how it's being used, but also how can we use it. And this is the part, because I really don't like this kind of apocalyptic discussions. So from a constructive and creative point of view, like we do know that AI algorithms are in many of the things we use. It can be fun things. This is like a new feature that was launched 2 days ago, where it looks at your picture and it maps it to a painting that looks like you. To like spell checkers that we use in our phones all the time. To recommendations on platforms like Netflix or any other things, to self-driving cars, AlphaGo. But then we don't hear these stories, which I think are much more important. This is like people who are not necessarily experts, people who don't work for the largest companies that are actually using machine learning in useful ways. So this is like story of Japanese agriculturists that used already existing algorithms to actually automate their farm for knowing where the cucumbers are ripe, so they crop them. And this one is an example of researchers that use an ImageNet like training algorithm. It's called VG16 if you're interested in the nitty-gritty details, to detect when you have like skin problems, like skin cancer. So these were not necessarily like coming up with an entire new design for an algorithm or coming up with an entirely new paradigm for it, but actually using it for problems that they had, where they had access to the data and they could use it in responsible ways. So how do we make more of this? There are a couple of big, very good websites. This is my favorite one. I would highly recommend it. It teaches you very practical and pragmatic ways how to get started with machine learning, how to create your Amazon instance in 20 minutes, and then how to use it for solving problems that you would have or creating things that you would like to create. So yeah, I'm very curious to see what you guys would make with it. And thank you very much.